students, welcome to physics class. Today we will discuss about the maximum height and range of a projectile. We know that the path of a projectile is a parabola. If u is the initial velocity and theta is the angle made by the projectile with the horizontal, then u can be resolved into two components. Ux is equal to u cos theta and uy is equal to u sin theta. And the maximum height is h and the range is r. In the vertical plane or in the vertical direction, a is equal to minus g, that is ay is equal to minus g, because there exists a change in velocity, so there exists acceleration in y direction. In the case of horizontal direction, ax, the acceleration component along the x direction is 0, because ux is equal to u cos theta remains constant throughout the motion. When there is no acceleration, we can say that the velocity component is constant. And the definition of maximum height is the maximum vertical displacement covered by the projectile is called as maximum height. The maximum vertical displacement, the maximum vertical displacement is called as maximum height. That is the displacement of projectile until its velocity becomes 0 is called as maximum height. And range is defined as maximum horizontal displacement. Range is defined as the maximum horizontal displacement. When the projectile is projected from the point O and the projectile reaches the ground at point X, then the distance between O and X is called as range. The distance between the point of projection and point of landing is called as range. This is the horizontal maximum displacement, and height is the horizontal, not a horizontal, vertical maximum displacement. Let us take the equations of motion. V square minus u square is equal to 2as. In a vertical motion, that is along the y direction, there exists some initial velocity uy and the final velocity v becomes 0. We know that uy is equal to u sin theta, and along the vertical direction we have already know that the acceleration is equal to minus g. A is equal to minus g, and the displacement is nothing but the maximum height. By substituting these values, we get 0 square minus u sin theta whole square, which is equal to 2 into minus g into h. By squaring this term, we get minus u square sin square theta is equal to minus 2g h. Here minus gets cancelled, and by separating h we get u square sin square theta divided by 2g. This is the expression for the maximum height reached by the projectile. Similarly, in the case of range, we will take the horizontal displacement. In the case of maximum height, we will take the vertical maximum displacement, whereas in the case of range, we will take maximum horizontal displacement. We know that from the expression S is equal to ut plus half at square. Here S is replaced by r, since S, the displacement is along the horizontal. This horizontal maximum displacement is range, so S is replaced by r, and u is along x-axis ux, which is equal to u cos theta, and along the horizontal component acceleration is equal to acceleration is equal to 0, because the velocity component remains constant. And t is equal to time of ascent plus time of descent, which is equal to time of flight, whose value is 2u sin theta by g. By substituting these values in this expression, we get r is equal to ux into capital T plus 0, because here a is equal to 0, so the whole term will vanish. R is equal to ux means u cos theta, and t is 2u sin theta by g. By multiplying, we get 2u square sin theta into cos theta divided by g. R is equal to, here 2 into sin theta into cos theta is replaced by sin 2 theta, because sin 2 theta is equal to 2 sin theta cos theta. So u square sin 2 theta divided by g. This is the expression for range of a projectile. This is the expression for the range of the projectile. And maximum height is given by h is equal to u square sin square theta by 2g, and range is u square sin 2 theta by g. Thank you.